morning and welcome to the Royal Swedish Academy of Sciences. Welcome back to all of you who were here yesterday. I see many familiar faces here. The Academy met in session again this morning to award this year's Nobel Prize in Chemistry. And we are now ready to announce the prize. I'm Göran Hansson, I'm the Secretary General of the Academy. With me today are two members of the Nobel Committee for Chemistry. To my right, Professor Sara Snogerup Linse, and to my left, Professor Olof Ramström. I will read the announcement in Swedish, then in English, and I'll read the citation also in German, French, and Russian, as usual. Then we will hear remarks about the Nobel Prize by Sara and an introduction to the science behind the prize by Olof. And later on, we hope to have one of our new Nobel laureates with us on the phone line. This year's prize is about a rechargeable world. Årets pris handlar om en laddningsbar värld. Kungliga Vetenskapsakademin har idag beslutat att utdela 2019 års Nobelpris i kemi. Gemensamt till John B. Goodenough, M. Stanley Wittingham och Akira Yoshino för utveckling av Lithium-Ion Batterier. The Royal Swedish Academy of Sciences has today decided to award the 2019 Nobel Prize in Chemistry jointly to John B. Goodenough, M. Stanley Wittingham, and Akira Yoshino for the development of lithium-ion batteries, für die Entwicklung von Lithium-Ionen-Akkumulatoren, pour le développement des batteries lithium-ion, za развитие Lithium-Ionych Battery. And here are, I thought you liked that prize, it sounded so, good to know. Some brief biographic data about the new Nobel laureates. John B. Goodenough was born in Jena in Germany in 1922. He obtained his PhD at the University of Chicago and is currently affiliated with the University of Texas at Austin in the United States. Being born in 1922, Dr. Goodenough is the oldest Nobel laureate ever awarded the prize. Dr. Ashkin, last year's physics laureate, is actually a couple of months younger. M. Stanley Wittingham was born in 1941 in Nottingham in the United Kingdom. He got his PhD from Oxford University in the UK, and he is today at Binghamton University of the State University of New York system in the United States. Akira Yoshino was born in 1948 in Suita in Japan. He is professor at Mayo University in Nagoya, and he's also affiliated with the Asahi Kasei Corporation in Tokyo in Japan. And now I'd like to ask Sara Snogerup Linse of the Nobel Committee for Chemistry to make some remarks about the prize.
Okay, thank you, Jan. This year's Nobel Prize in Chemistry rewards the development of lithium-ion batteries. We have gained access to a technical revolution. The laureates developed lightweight batteries of high enough potential to be useful in many applications. Truly portable electronics, mobile phones, pacemakers, but also long-distance electric cars. The batteries no longer weigh 2 tons, but 300 kilograms. The ability to store energy from renewable sources, the sun, the wind, opens up for sustainable energy consumption. To make this possible, the laureates solved a number of chemical challenges. They tamed a reactive element. They built 2 homes between which lithium ions can travel in a controlled manner. Use, recharge, many hundred times, to make a durable battery. I now hand over to my colleague, Olof Ramström, who will provide you with more details in a highly short story.
Thank you so much, Sara. That's absolutely correct. This is a highly charged story of tremendous potential. And as you, of course, have understood, this is all about batteries. But before we can actually understand more of the very important discoveries that our three laureates have made, we need to maybe remember a little bit about how actually a battery operates. For example, a AA battery you can see here to the right. So as you see to the left here, this is a simplified drawing of a typical battery. So you can see it contains two electrodes, an anode and a cathode, and those are separated by some kind of electrolyte. It's typically a liquid that can host or accommodate charges or ions. And sometimes you also have a barrier between these two electrodes, so they're physically separated from one another so you don't get short circuits. And what actually happens in a battery is that you have chemical reactions taking place at each of the electrodes. And that generates electrons that can then pass through the circuit, the electric circuit, and power whatever electric device that you want to power. So when you actually look at this simplified drawing here, it may look relatively easy to make a battery, right? However, that is definitely not the case. It's really very, very hard to produce, to design and develop well-working and efficient batteries. And just as examples, some of the batteries we're still using today, like the lead-acid battery and alkaline batteries, they have their origin in the 19th century. So it's really a hard job to make a new good battery. Yet, that's exactly what our three laureates have done. They have taken on this challenge, and their discoveries have led to the development of the phenomenal, fantastic lithium-ion battery. So what is this all about then? Well, as you can see, the name reveals it. This is about lithium. And to the left here, you have a small piece of the periodic table, and you can see that lithium, the red box, has atomic number 3, and it's a very small element, and it's actually the lightest metal we have. And it actually floats, at least temporarily, on water, if you would try that. And that is a very good and attractive kind of property of lithium, because that means that you can pack lots of lithium atoms in a battery, and you still have light weight and a small volume. Another property of lithium that is also very good, as you can see here to the right, is that lithium has an enormous tendency to give away one of its electrons. And so you can see that lithium atoms, they have 3 electrons, and it's very easy for lithium to give away one of the electrons, and then it becomes a positively charged lithium ion, as you can see there to the right. However, these are fantastic properties, but there is a flip side. And the flip side, as you heard a little bit from Sara here, is that it's a fantastically reactive element. So for example, it reacts quite vigorously with water. So in order to use lithium in a battery, you really need to tame its reactivity. And that's exactly what the work of the laureates really have achieved. So how did they actually do it? Well, let's jump directly to the 1970s. So around in the middle of the 1970s, Dr. Stanley Wittingham discovered a fantastic material that can be used as a cathode together with the lithium. And that material, as you can see to the right here, was titanium disulfide. And as you can see a little bit in this zoom-in circle there to the right, titanium disulfide is actually a layered material. So you have layers, and between the layers you have gaps where lithium ions can sneak in and go out freely. And also very, very advantages with this type of material, it has a relatively high potential towards lithium. So when you put this together in a battery, you can get a quite high potential of 2 volts. That's already quite good for any battery. Remember, some of the alkaline batteries we use today are 1.5 volts, right? So 2 volts is already quite good for a battery. However, during this time, it also became quite evident that lithium metal is not really quite optimal to have in a battery, right? Because you can have problems. So the idea came up how we should replace lithium with something else. And then you have two challenges. One is, with what do you actually want? Can you replace it with? And secondly, whenever you replace lithium metal, the potential will come up, meaning that the overall battery potential will go down from, in this case, then 2 volts to less than 2 volts. So another challenge would be how do you maintain the battery voltage or even increase it? And that's exactly what happens next. So in around 1980, Dr. Goodenough, he discovered a really phenomenal, fantastic material that could actually do this. And that material, as you can see here, was based on cobalt oxide. And again, as you can see in this zoom-in circle there, this is also a kind of layered material that have gaps between the layers where lithium ions can go in and out freely. And because this is an oxide material, it contains oxygen atoms, then you get a fantastic high potential towards lithium. So when you put this together with the lithium in a battery configuration, you will get an enormous voltage of 4 volts. And this is a gigantic leap in the battery world from 2 to 4 volts. It's a huge leap. However, as you can see here, we still have the lithium metal as one of the electrodes here. But so how do you replace that? And that's exactly what happened next. So in the 1980s, Dr. Yoshino here, he started working on trying to figure out ways to replace the lithium metal. And he started looking at different types of carbonaceous materials. And he found out that certain qualities of, for example, petroleum coke, as you can see here to the left, when you treat it in the right way, also contains this kind of layered structure where you have gaps where lithium ions can go in and out. And furthermore, this material, these carbonaceous materials, had a fantastically low potential compared to lithium. So when you put this together, this material together with Goodenough's cathode material, you can maintain a fantastically high voltage in this particular battery of 4 volts. And this, what you see here, this is the configuration that we have in the modern days lithium-ion batteries. So the way it works is that you have 2 electrodes. Both of these electrodes are materials which can take up and release lithium ions at different potential. So what happens here is that during discharge, you have lithium ions going from one material across the electrolyte and into the other material. And at the same time, you can see that the electrons are passing through the circuit, driving your electric device. And this makes it very safe, because here you don't have any trace of lithium metal. So it makes it much safer. And also, what is very important here is that you can turn this process around. So if you plug this battery into a power source or a charger, you can reverse the process and you can recharge the battery. And of course, this process you can do many, many, many times, hundreds of times before the battery actually degrades or loses its capacity. So you can see that these discoveries really led to the development of a fantastic product, the lithium-ion battery. And as you can see on the next slide here, we have found applications, this type of battery has found applications in many, many, many instances. And you can see everything from small mobile electronics, if nothing else, not the least the mobile phone you have there in the middle that we're all using all the time, every day. Most of us at least. But also larger objects like vehicles, electric vehicles like bicycles and cars and other things. But as you can see to the right here, it's also increasingly being used as a complement to power sources, energy sources that fluctuate over time, like solar energy and wind energy, for example. So you can see that this battery has had a dramatic impact on our society. And it's very clear that the discoveries of our 3 laureates really made this possible. So it's really been to the very best benefit of humankind. So by that, I just want to leave the word back to Secretary Hansson.
Thank you, Olof. Thank you very much. So let's see if we have our new Nobel laureates, one of them available on the phone. Yes. Hello. Dr. Yoshino?
Yes?
Yes. Hello, Dr. Yoshino. This is Göran Hansen of the Academy again.
Thank you very much.
Thank you for being with us at the press conference.
Yes.
Now we have many journalists here, and I'm sure they would like to ask you some questions. Are you ready?
Yes, sure.
Yes.
Congratulations, Dr. Yoshino. This is Swedish television,
Thank you.
public service television. All this happened, all your work regarding the lithium-ion battery happened decades ago. Would you say that there was a long work period, or was there one moment when you realized, I have it now?
Yeah. I started the basic research on new secondary battery in 1981.
1991.
81.
81.
1981, yes. And I invented the current lithium-ion battery in 1985 by combination of carbonaceous material, negative electrode, and Goodenough with cathode materials.
So it was a process here that took some time, I gather.
Yeah.
Please, the lady next to Mr. von Eyck.
Yes, it takes a very, very long time.
Hello, my name is Anneli Megner Arn. I'm from Swedish
Hello.
TV4.
Yeah.
Arigato, sprashi, totemo ii deshita.
Arigato.
Yeah, I'm thinking one of our greatest challenges in our time is climate change. And
Yeah.
I wonder what you think about your research and actually what you hope that your research with your batteries will lead to when it comes to our future and climate change.
Yes. I think that the climate change is a very, very serious issue for humankind. And lithium-ion batteries can store the electricity, you know? So for example, electric vehicle is very suitable for the sustainable society.
Right. So it's important help in the attempts to improve the situation with regard to the climate. More questions? Yes, the lady right here on the floor.
Hi, thank you. Congratulations. And
Thank you very much.
I'm a reporter from Nordic Chinese Times, and I want to ask that what did you think about when you did this research? Did you think about it can be applied very largely to our normal life, or did you think that it will improve the environment, or did you think that it will help you or the company make money or something? Yeah, thank you.
what were your thoughts when you made
okay.
the discoveries?
Yes, I think that it is very important matter is curiosity, you know.
Sorry, could you repeat that again? The phone connection is not very good.
Yeah. Yeah. I think, are you all right?
Yes, please go ahead.
Curiosity is very important for the researchers. Okay?
Yes, so curiosity was a major driving force for you.
Yes, that's right. I think so.
Right. So curiosity-driven research that leads to great benefit for humankind. Any more questions? Yes. David Keaton from Associated Press over here. There, on the platform. Yes.
Thank you very much. Congratulations, sir, on winning this prize. You join a number of very prestigious laureates in winning this.
Yeah.
How did you react to earlier today when you received this call and you knew that you were now a Nobel laureate joining this history?
Mm-hmm. Amazing. Surprising.
You sounded happy when we spoke an hour ago.
Yeah.
Yes. Any more questions? If not, thank you very much, Professor Yoshino, and we look forward to when you're coming to Stockholm in December.
Yeah.
Thank you.
Thank
Bye-bye.
you. Bye-bye.
And now, questions to the panel. Yes, gentleman over there.
This is Yiming Fu from China's National Xinhua News Agency. I would like to, it seems to me that this year's prize is a cross-disciplinary research between chemistry and physics. So I'd like you, the panel, maybe expert, give us some comments or elaboration on the significance of cross-disciplinary researches in basic science in the future to potentially benefit the humankind.
Let's hear from both of you. Who would like to start?
Well, I can start. It's absolutely correct. This year's award is very much a multidisciplinary effort. So you can say that we have had input from all sorts of chemistry, not the least electrochemistry, which is of course at the heart of this award, but also other branches of chemistry that had to come in to make this reality. But also, as you say, it's also definitely connected to physics. And if you want to go even one step longer, it's also definitely connected to engineering and development of the actual products. And so I would say that this is definitely a very good example of when all these all these disciplines can come together, and you can find touching points between the disciplines that can lead to such an important, and dramatically high impact product that we've seen here with the lithium-ion battery. So I think that's a really very good comment there.
Sarah, would you like that?
I could add that, I foresee that a lot of new discoveries in the future, important discoveries, will be interdisciplinary. So it will require scientists in different fields that are experts within their fields, but to be able to communicate. And chemistry is sort of in the middle. It's between physics and medicine, and everything is molecular or atomic. So chemistry is always going to be part of many new developments.
Maria Gunther?
Yes, Maria Gunther from Dagens Nyheter. Thank you very much for this prize that we have been waiting for some years. I would like to know, will John Goodenough be here in December?
We have not been able to reach him, unfortunately, so we don't know. Any more questions? Have you had your morning coffee yet? Yeah, there's a gentleman that has had his morning coffee.
Yes. Stefan Trump from the German news agency DPA. Thanks again for this conference. I'm wondering also what, in your opinion, what kind of contribution this development of batteries is to regarding solving the climate crisis, or if you think that there's a lot of work ahead of us still.
Well, I can start. Definitely this, we have seen development that this battery can contribute to at least reduce the climate effects that we may see, that we are seeing. And the reason I'm saying that is because we see a switch from fossil fuel transportation to electrically driven transportation, and that is at least on the local level is a direct effect on the environment. But also you move the powered production from the cars, from the vehicles, to power plants where you more easily can, manage the production. And also we can see that this, as I mentioned in the last point there, this battery type or similar battery types, they are increasingly being used as complement to these kind of renewable sources, energy sources that fluctuates over time, like solar energy. So you can have the battery being charged when you have access to solar power, and then at night when the sun is down, you can actually use then the power that is supplied from the batteries. So definitely those two things that are really making an impact, and probably will make much more of an impact in the future. Yes.
Yeah, and you're right that this is one of the main pressing issues for humankind to solve for the future, and development of these batteries is a huge step forward so that we can really store solar and wind energy. But of course there's very active development going on to make even better batteries of other materials like iron phosphate, or even easier to produce at large scale.
Thank you. Yes, please, over there.
Åsa Husberg from the Nobel Prize Museum. You weren't able to connect to Goodenough, but Wittingham and Yoshino, could you say something about their reaction? We have a lot of people have thought about this prize for some time, so were they like, finally, or was it a surprise, if you're able to say?
None of them used the word finally, but of course they were delighted to hear the news. I don't know if they had been waiting for the news for years, but they were very happy, both of them. We spoke to Dr. Wittingham, who's actually been attending a conference here in Europe, and Dr. Yoshino was in Japan. Please.
It's a question somewhat related to the previous one about the benefits. The Alfred Nobel grant specifies that this should be for the greatest benefit of mankind. So the question to the panel is, do you have ongoing discussions about what that actually means? And today we're looking at questions about the benefits for climate change. Has the panel, over the years, reflected on what that actually means, and has that changed as the issues that preoccupy the concerns of mankind have also changed?
I'm sure we can all comment from that. Let me start. The stipulation in Nobel's will that the work should be of greatest benefit for humankind, as we state in our news translation, could mean, of course, benefit in different ways. And the benefit here is obvious, and that's the importance of this chemistry and technology for a more sustainable world has, of course, increased its relevance in recent times and made it a very timely award now, although several of the discoveries were made quite some time ago. If you take a prize like yesterday's physics prize, there is no such immediate application. But we firmly believe that knowledge is of great benefit for humankind. So the benefit can be of different types. There is a benefit in the knowledge, and there is often a benefit in the application now or at later times.
Yes, and as Göran said, the benefits can really be of different kinds. It can be applications that we can all see in front of us and appreciate, but it can also be that the discoveries change the way we think, and that gives us a leap forward. So there can also be prizes that really change. They change the paradigm from what it used to be, and we now have new insights.
Any more questions? If not, then we'll close the press conference. Thank you very much for your interest. Now there'll be opportunities for interviews with experts and panel members. Thanks so much.
Olof Lernström, you are a member of the Nobel Committee for Chemistry, and the prize this year is for the development of lithium battery. What is special about lithium battery?
This is a fantastic battery. The lithium-ion battery is a fantastic battery because it actually is based on a very, very small element in our periodic table, lithium, which has such enormously attractive properties. And you can actually, that leads to that you can get a very lightweight and small volume battery with high power and high efficiency. And that's exactly the benefit of this battery. So you can actually, that's actually enabled the mobile revolution. This battery actually enabled the revolution of the mobile world, I mean, mobile phones and laptop, whatnot, right? So it's really made a very dramatic impact on our society. So I would say that the lithium, the basics is the lithium, and how to tame that into a battery. That's really what is so special with this battery.
Why do you have to tame it?
Because lithium, it's an interesting element. But it's very reactive, right? It reacts, for example, quite vigorously with water. So if you put it in water, you will have, lots of gases formed and so on, right? So you need to be able to really handle that kind of reactivity. But the reactivity is also connected to what we need, right? We need to have the electrons, right, from the lithium, and that is related to the reactivity. So really this award is all about trying to tame that and get it into this small battery package and really use it for what it's very useful to do.
So the three laureates, they have tamed lithium. Did they work together?
No, I don't think they work together. They made very important discoveries, individual discoveries. And together, those discoveries really led to the development of this phenomenal battery.
How long time did it take?
Oh, it took quite a few years because it's really very hard to develop a good battery. It's a difficult process. So it not only does it require, very important discoveries on the scientific level, but also you need to put those scientific discoveries, you have to optimize them and put them together so you can form this battery. So it takes some time to do that because there are many challenges to solve on the way, but they managed.
If you had to think about a metaphor for this invention, what would that be?
Oh, that's a very hard question. I would, that's a hard question. Maybe you can think of this battery is essentially, it's kind of about the rechargeable world in a sense, right? So what this has really led to is that we now have charge, we have power anywhere we go, essentially, right? And really, power is very important to us, to our lives. So maybe some kind of metaphor is that it's all about charging the world and have access to energy wherever we go. Maybe something in that direction.
So in what way did it influence our everyday life?
Yeah, as I tried to mention, so this battery is such a very, very good battery, and also high-powered battery and high energy efficiency battery. So this is actually has found applications almost everywhere. So ever since this was introduced to the market, to the public, we see this battery everywhere. We see it in mobile electronics, of all sorts of mobile electronics, nothing else than mobile phones that we all use, most of us use every day, but also laptops, other small equipment like cameras and whatnot. But we also see an enormous, impact on the transportation sector. So this type of battery has made a large instep in the switch from fossil fuel transportation, like petrol-driven cars, for example, where we now are in the middle of a switch to electrically driven cars, and that's enormous impact on society. And as I also want to mention is that this type of battery has so good performance qualities, so you can actually combine it with energy sources that really fluctuates over time. So you have, for example, solar energy, where you have sunshine during the day, which then can be used to power the battery. And then at night, when the sun is down, you can use the energy from the battery to power the grid. So really, we can see an enormous dramatic effect on society because of this fantastic battery.
So what about the future if we are moving towards a fossil free fuel society. Do you view lithium batteries in there or some other kind?
Yes, yes. I think we are actually only in the beginning of that development when it comes to the real environmental effects here, and for example, transportation and the powering of the grid. So I think we will see much more of that in the future, not only maybe from the lithium-ion battery, because that's of course developed continuously in even better and better versions of it, but also other types of batteries that may be discovered in the future. And I think that's really the future, to have this effect where we actually use batteries more and more for our powering.
One of the laureates, John Goodenough, is the oldest ever Nobel Prize laureate, 97 years old. Can you tell us a little about him and his work?
He is a fantastic scientist, and you can say that he has been working in this field for many, many years, and he never retired. So he's still working in this field up until this age. He's still going to the lab pretty much every day, as far as I know, and he still makes contributions to the community when it comes to the battery, science and the battery development. So he is a really remarkable person. He is really burning for this field and really made very large contributions.
And finally, if you had just 30 seconds to describe the prize, can you tell us what makes you most excited about it?
That's an easy question. So what makes me most excited is that this is a prize, this is an award, which that many disciplines have to come together to make this work properly, to make the final product work properly. So here we have an award where you have a combination of course, chemistry, which is at the heart of these discoveries, and definitely basic science discoveries. And combine that with physics and technology and engineering, that has then led to a fantastically useful product that we all can use every day. I think that's the most exciting about this award.
Thank you, Olof.
Thank you.
Thank you for taking your time.
It was a pleasure. Thank you so much.